Alrighty, so let's go to the classic. This is a favorite of mine. This one's kind of easy, not gonna lie. And we're gonna try to be a little bit faster on this one. Okay? And we're gonna go to the same pace how I would do it on an exam. Okay, so on continue, travaille fort. Let's go. So this question is a highlight this in blue. It's TVM. It's a flowchart question, so you could use my flowchart to help you find which formula to use. And we're going to read it together. We're going to identify some pieces together, and then we're going to identify which formula to use or formulas, and then we'll jump into it. So your job pays you at the end of the year, okay? It pays you at the end of the year. All right, this is important. And today, you seem to be December 31st. So if we're December 31st, when are we? Are we at the end of the year or are we at the beginning of the year? If we're December 31st, what day is that of the year? We're at the end. Okay, so we're at the end here. Just important. When you have wordy questions like this, try to contextualize them. Okay? And you receive your salary of $125,000. Okay? So far, what we understand is that at the end of every single year, you receive $125,000. Okay? That's pretty cool. All right? Now you want to start saving for retirement beginning next year. Okay? Beginning next year, you want to save money. Now let me ask you all a question. Even if you want to begin, call it on January 1st, right? So the beginning of next year. When do you receive your money? At what time? When do you get it? Do you receive it until when? What date? Somebody tell me. When do you receive your money? You receive your money at the end of the year, okay? So no matter what, even if you want to start investing at the beginning of the year, you cannot. You can only start investing at the end of the year, okay? The reason why is because you spent all of your previous money, okay? Just to give you context. You have decided that 1 year from today, all right, you will begin depositing 20% of your annual salary in an account that will earn 4.5% per year. Let's break this down into two pieces. So 20% of your annual salary. Can somebody tell me in the chat, what is 20% of 125,000? What is 20% of 125,000? 25K. That's a lot of money. Amazing. 25K. And then you're going to deposit that amount of money into an account that earns 4.5% per year. This is essentially the interest rate that you should expect to have. So your K is equal to 4.5%. Your salary will increase by 3% per year throughout your career. Okay? So what would that be? All right? If it increases by 3% per year, would you call this your G? Would this make sense to call this G? Right? Because you're investing a portion of your salary every year, and your salary increases every year. So what you invest will increase every year by the same amount. So 3%, would it be fair if we call this G? Could somebody say yes in the chat or no? Could this be G? Yeah, okay, perfect. So G is 3%, amazing. Now we're gonna ask you, how much money will you have when you retire 50 years from today? Okay? Can somebody tell me what this is? What is 50 years? Is that like our G, or N, or I, or K, or payment? Hell yeah. It's our N. So N equals 50. All right? Solid stuff. So already here, it seems pretty straightforward what we need to do. I'm not gonna lie, right? This is a flowchart question, so you should use our classic flowchart, right? Now, I'm not gonna go through the pain of taking it out and putting it into a screenshot. What I want you to remember is that if you were on an exam or doing a mock exam or whatever, like we are right now, you should have your formula sheet open next to you, such that you could go on your formula sheet and go through the steps and say, okay, Let's do this together. Are these payments happening forever, or are these payments happening for a definite amount of time? That's the first step in our flow chart. Okay? Marianne is a gangster. But yes, that is the formula. She's a gangster. She got it. Straight out of the bank. I love it. But yeah, these payments are happening for a definite amount of time. So you would go above the first part of the flow chart. Then you would say, are these payments happening at the beginning or at the end of the year? They're happening at the end. Amazing. So then we go into the next part of our flow chart. Then we say, are these payments going to be the same every year, or are they going to be growing every year? They're going to be growing. And for that reason, we are indeed dealing with a growing perpetuity. Very good, Marianne. Very good, Waleed. So, yeah, of course. But I mean, there's only one type of growing, and oops, my bad. My bad. Growing annuity, my bad. It's a growing annuity. Sorry about that. I just read the chat. It's a growing annuity, guys. Don't forget that this is an annuity, because an annuity finishes at a specific date. It's not going on forever. In this case, we're starting at t equals 0, but we're finishing at t equals 50. Okay? So we should not. Yeah, Shane, for sure. Shane was like, whoa, everything that I learned is wrong. Like, it's false. But now you're good. This is an annuity because we're starting at 0 and we're finishing at 50. There's no other way to go about it. Okay? Very important. So it's getting pretty straightforward. We know we need to use a growing annuity formula. That's pretty cool. What I'd like to say, I guess I could zoom in myself to find the page 6. I'm gonna get the formula out for y'all. I'm gonna get the formula out for y'all. And I'm gonna highlight a few things. So because we're dealing with a growing annuity, what I want you to understand is that the formula is interesting. The formula is PP0, payment 1 over K minus G. Then that's going to be like this, 1 minus, oops, 1 plus G, 1 plus K, this to the power of N, like that. Okay, sorry that it looks kind of ugly, but I just want to do it quickly. But the first thing that I would like to say, all right, on an exam, what you did is you highlighted the information, you figured out, okay, we have pretty much everything that we need, right? We have our K, we have our G, we have our N, okay? We know that our K is 4.5%. We know that our G is essentially 3%. We know that our N is 50. However, do we have our payment 1 yet? And if so, can somebody tell me what's our payment 1? Somebody in the chat tell me what's our payment 1. What is our payment? Okay, our payment, right? It's related to our salary, and it's going to be a portion of our salary, right? Because we're saving an amount of our total salary every single year. And we said that today, 20% of our salary would be equal to $25,000. So if we know that our salary here is $125,000, we know that our salary here would be $125,000 times 1 plus G, what would be our payment at T equals 1? Because that's what we want. We want payment 1. We want payment 1, not payment 0. Okay? So I need a few people to tell me in the chat, and I'll write it down again onto the screen. Right? Just for everybody to make sense of this. Our payment is a function of our salary. And from our salary, we're going to deposit 20% is invested. Okay? And we know that 20% of our salary is $25,000 today. So that's at T equals 0. However, that would be payment 0. We want payment 1 at T equals 1. So A few people wrote in the chat, you guys are amazing. Exactly. You would simply do 25,000 times 1 plus 0.03, or you could do 125,000 times 1.03 times 0.20, because 20%. Now, both these amounts, I believe it's unanimous in the chat that payment 1 is equal to this right here. Okay? I feel like we're all okay with that. I just wanted to give you the step-by-steps here. Now, on an exam, they may do that to you. They may ask you to kind of be logical with the perspective. That's exactly what we did here. We had to get a little bit logical with it, okay? Before we get to the next step, so far so good. Are we okay? Quick yes or no. Are we okay? Just yes or no in the chat. Yeah, okay, amazing. So what we'll do is we're gonna rewrite everything. So we know that payment 1 is 25,750. We know that K is 4.5%. We know that G is 3%. We know that N is 50. Okay? If we go back into our flowchart, and if you go back through all of the different formulas that you have, it's really interesting. How many formulas do we have for our growing normal annuities? Can somebody tell me in the chat, how many formulas do we have for normal growing annuities? Waleed says 1. Do you guys agree with that? Is there only one formula for normal growing annuities that we have on hand? Yes or no? Yes, exactly. We only have one formula. And that formula, does it give us the present value or does that give us the future value? Which one does it give us? It gives us a present value. But that's the only formula that we have. And because we're dealing with a growing normal annuity, we could only use that. There's no other formula that we could use. So the first step for us to do is to find the present value, right? To find the value at t equals 0. It's going to give us the present value of all those future payments. And then we're going to compound it all the way to T50. All right, so we're going to build interest on it all the way to T50 by just doing a compounding interest formula. Okay, so what I'd like you to do is I'd like you to tell me what is the present value if you use the formula of what we just discussed. Knowing that this is the formula, what is the present value of this growing normal annuity? That's the first step. What is the present value? So Shane says 883,498. Well, I'm gonna give y'all like 2 or 3 more people to give it a shot, and from there we'll do the next step. Okay, so it seems like we're on the same page. I'm gonna let one more person give it a shot. One more person to give it a shot. We're doing good on time, so that's dope. Amazing. Thank you so much. So the present value is going to be equal to the following. You guys are amazing. Cool. So now we have our PV0, but we need to bring it all the way, right, to period 50, right, to get our future value 50. Now, in order for us to do it, it's very easy. All that you gotta do is you take your PV0 times 1 plus k to the power of what? The power of 10, 5, 6, 50, a million. The power of what? Power of 50. Exactly. Now, could somebody tell me what does that give you? Somebody tell me what would be the future value of this person that is investing a lot of money every year for 50 years. I'm gonna let a few more people to give it a shot. Okay, one more person. So $7,980,320, something like that. Perfect. That's a lot of money. That's a lot of money for saving 20% a year for 50 years. That's not bad. I'd be okay with retiring with that money. It's not. I'll be fine with that. But all jokes aside, wait, no, if it's 50 years, I'll be 72. Hmm, interesting. Maybe it's not enough. I'll be a little bit too old. Anywho, but overall, this question is actually pretty straightforward, right? What we did is we highlighted the important like pieces of information. We know that we're in time value of money, so there's only up to 4 to 5 variables that we need to look for. So what we did is we identified them. Obviously, when we had to seek our payment, it was a little bit more nuanced because we had to remember what does our payment actually consist of. But as soon as we did that, we identified, okay, well, what type of formula do we need to use? And thanks to the flowchart, it was obvious. We knew because these payments are happening for a very specific, definite amount of time, and that they're occurring at the end of the year, and that these payments are growing, we know to use a growing normal annuity formula. All right. And as soon as we know that we only have one growing normal annuity formula. So we had to plug everything in, get our present value, so PV0, and then compound interest all the way to FV50, because that's what we care about. We want how much money you'll have, in other words, the future value at year 50. So questions like these on your exam, they're not complicated, but this was definitely an exam question. The reason why students will maybe not get the answer correct is because you're not taking your time with it. It's okay to identify the pieces. And once again, there are only so many variables you need, okay? And by using a timeline, this makes much more sense to us because we know we're at PV0, just gotta bring it back to FV50. Before we move on, is this okay? Are we good? Yes? You see this on an exam, you know exactly what to do? Solid. Ça marche. We're doing good. Next question. Flowchart all the way. You know what I'm saying? It goes hard. Alrighty. This one's a fun one. This one's a fun